Hi everyone, welcome back to our channel. In today's video, we will be showing you how to automate meshing for the movement of the intake valve, exhaust valve and the piston head from the TCC3 IC Engine test case. Before beginning, however, we need to create the topology for the case with the valves in their initial positions and piston head at top dead center. You can check out our series of videos on how to create the topology here. The piston head and the intake and exhaust valves all move according to the crank angle. The piston head completes one cycle every 360 degrees from top dead center to bottom dead center and back to top dead center. The piston motion is classified into four parts: intake stroke 0 to 180 degree, compression stroke 180 to 360 degree, power stroke 360 to 540 degrees, and exhaust stroke 540 to 720 degrees. The intake valve is usually open during the intake stroke and the exhaust valve during the exhaust stroke. Methodology of automation. As in the previous automation of the piston bowl, the piston head of the current geometry moves according to the crank angle. The values of the intake and exhaust valve lifts at a particular crank angle are given in an Excel file. The script automatically reads this and translates the intake and exhaust valves according to the values in the Excel file. Automation using the API. Now we move on to automation. The automation is carried out via the script and consists of the following main steps. Input the stroke of the piston, the number of grids to be generated per crank angle and the total crank angle. Translate the piston head and the corners to be translated based on the crank angle. Read the valve lift data and translate either or both the intake and exhaust valves and their corners based on the crank angles given in the Excel file. Change the densities of the block edges at the piston head and the valve. It should be noted that the corners to be translated for the piston head and the valves are given manually in the UI, and the corner groups are then specified in the API script. Also, not all corners assigned to the valves are moved. Only the corners seen here translate along with the valve surface. The density of the group of parallel edges just above this is changed based on the translation. Salient features. Multiple grids are generated seamlessly without any user intervention. The valve lift timings can be changed by editing the Excel file. This is useful in optimization studies. The script is reproducible, meaning that the same script can be used to generate grids on different engine geometries. Thank you for watching. If you like this video, leave us a like and subscribe to the channel for new videos. If you have any questions or any comments, feel free to leave it below. Follow us on our social media pages. Links are posted in the description.